All right, section 3.1, day 3, right? I know, this is a long section. All right, so last time we had left off on talking about numeration systems that use our symbols, but they're not base 10. So we were looking specifically, we had encountered 3 of them that we left with. Let's find them. Base 3, base 7, and base 12 is what we had chatted about briefly. And what we're going to do next is we're going to do like we did with our friends with the Babylonians and the Numans and the Babylonians and the Mayans and the Romans, all of them, where we looked at what comes next and what came before. So we're looking at what's preceding this number and then what is succeeding this number. So pay special attention to the base that you're working with. Like this first one says we're in base 5. So remember there's no 5s in base 5. So this is asking us for the number that comes before 1, 3 in base 5 and the number that comes after. So what comes before 1, 4 in base 5? What comes before 1, 4?
1, 3.
1, 3. So 1, 3 comes first. So this is 1, 3 base 5. The next one would be 1, 4 base 5. I'm just going to write them as though they're in order. Whoops. So here's the one before. This is the one we're given. What would come after 1, 4? Well, it would be 1, 5 if we had a 5, but we don't have a 5. Nope, there's no 5, 6, 7, 8, or 9 in base 5. 2, 0. So when we run out of digits in the ones place, which we would have if we'd hit the number 4, we've run out, we would actually go up 1 place value on the second digit. So the 1 becomes a 2, and then it zeroes out. And you can kind of think about it in the same way as what happens when we run out of digits in our system, right? What happens after we hit 1, 9? Well, we go to 2, 0, and it works the same way in all systems. We've run out, so we go to 2, 0, and each time we want to make sure that we're writing the subscript next to it that it's base 5, because the understood base, if you don't write the 5 as a subscript, is that you're in base 10. So we want to specify that we're in a specific base if it's not base 10. Okay, so in this case, kind of like we talked about before too, this one's the easier one to find, right? It's easy to take away from the 4 to make it a 3. It's very clear. It's the other one that's a little bit more complicated to think about, right? How do I go from 1, 4 up? Oh, I don't have a 1, 5, so now I have got to go to 2, 0. Okay, the same thing's going to happen on the second one. We're in base 12. So we've got the number in the middle here, T, 0, 0. This is base 12. And I think that we talked about last time, and I think I actually told you backwards between our 2 books. I think that I had told you that in our book that they used A for the number 10, and in fact I know I did, which is definitely what we do in my contemporary book, and I had them backwards in my mind. So let's actually come back over here for an adjustment real quick and make a comment. This book, if you do the A's and B's, I'm going to be fine with it. So if you just like the A's and B's and want to do that, that's good. There you're going to use a T for 10 and an E for 11. That's what this book is going to use. So when you get to BB, they would write EE, not BB. So I'm sorry about that. I definitely had them in mind the other book when I was doing that. So it'll come into play in this problem here in just a minute. TE, there's our one. So we're in base 12. The T, right here, this T is the number 10. So that doesn't mean I've got 1,000. So don't go changing it to a 10. But in some sense, I have 3 placeholders. I have a 10 in this placeholder, like confined in that single place, and I have zeros in these. So we'll look at how we convert these later. But the number that comes after is the easy one in this case. What comes after T00?
0,
Yeah. So this is the easy one, T01. Usually you get one of them easy and one of them hard. That's the typical way to expect here. And we would write down that we're in base 12. Problem is the one before. So in an effort to sort of think about what we do in our system, let's change the value and to work with something a little bit different. Let's say we had the number 800. I just made it up, but I wanted the zeros on the end. 800. What comes before 800? 799. So let's think about what we did. Well, the 8 went down 1, right? 8 went down to a 7. And the ending digits are sort of the biggest thing possible. Do you see that? The biggest digit that we have possible is a 9. So the 8 became a 7, and then I had the largest digits possible after the 7. So let's think what we would do if we think about it from that perspective on our number, the problem we're given, the T00. Well, the T needs to go down 1. So T is a 10. So what comes before 10? 9. So we're going to change the T to a 9. 10 turns into 9. And then I need the biggest value possible in base 12. So what's the biggest value possible in base 12? 11. And 11 is written as a E. They write 11 as E. Okay? So they write E, E here. So we went down 1 digit, 10 became 9, and we used the biggest value possible, which is the 11 value, EE, in the last 2 places. And this is, I need some more space here, let me shift it, in base 12. So the 2 answers are the ones that are before and the one that's after. So let's look now at what happens when we try to do conversions, because I think conversions will help to solidify what's really going on here, which is a little confusing. But the conversions are a little more direct, and all of it still mirrors what we did with like the Babylonians and the Mayans, specifically Babylonians and Mayans, by the way. So we have base conversions. So we're going to do base conversions in both directions. The first way that we're going to do base conversions is we're taking some other base, if it's base 3, base 8, base 12, whatever, and turning it into our base, base 10. So we're going from something into base 10. So what we're going to do is we're going to put the numerals in expanded form, right? So what is expanded form? Well, expanded form in our system is that if you had something like 543, I don't know why I said those and that didn't match, 543, we would say that this is 5 hundreds, and we would have 4 tens, and we would have 3 ones. That's expanded form, okay? And by the way, kids do this in school all the time with our base 10. They write expanded form. That is a very common practice in 2nd and 3rd grade, okay? Expanded form. And then the second step is to multiply the expanded form out. Now, for us in this problem, if we multiply it out, combine them back together, we get 543. That's not very intuitive. But that's because we're using base 10 values, right? 10 and 100 are showing up there. When we do this with other systems, we don't have base 10. We have whatever base they're in that we're using. So let me show you how it works. This first one is a base 2 problem. So what we're going to do is, what I do first anyway, to help me identify all the pieces, is that I write them all out individually with a placeholder underneath. And I write the value of the place that they're in. So this place is the ones place. It's always the ones place on the right. The ones are the units place. And then the base that I'm in is what I'm going to be using. So this is base 2, right? Base 2. So the next place value is the 2's place, because I'm in base 2. And the next one would be squaring that value. It's the 2 squareds place. And then it's the 2 cubes place. And we would keep going up powers of 2 for however many digits we have. Now, it's sort of weird to write it that way, but you can see where the numbers are coming from. And then to actually figure out what 2 cubed is, well, that's 8, and 2 squared is 4. So these are the values that I actually have there. I have 8, 4, 2, and 1, because that's what 2 cubed is. So whether you write it there or whether you write it in a moment, what we have is we have 1 in the 2 cubes place, 0 in the 2 squareds place, 0 in the 2 to the first place, and a 1 in the ones place. And this is 1 times 8. Of course, we have 0 in the middle, 0 here, and then 1 times 1. So this is 8 plus 2 zeros and a 1 for a grand total of 9. Okay, so here's what you should imagine. What's my next one? It's base 12. Imagine crayon boxes. Crayon boxes work really well for this. Okay, so crayon boxes come in lots of different sizes. Y'all know what I'm talking about. You have bought crayons before. I want you to specifically think of the crayon boxes that are in crayon sets of 8. That's a standard one for like the really little kids. They're usually the big fat ones, but a set of 8. And I want you to think about the set that's the one that is the envy of every child. It's the set of 64. Y'all know what I'm talking about with a sharpener on the back, yeah? Okay. So imagine somebody comes in, and some of the kids bring in these packages of 8, little ones, you know. And then some kids bring in packages of, you know, the 64 pack. They're, you know, making everybody else jealous. And some kids come back in and they have, you know, the box of random crayons. You know, all the lone misfit crayons in your house go into this box. They do in mine anyway. We have several boxes of these actually. And they're just a bunch of random crayons. And then you dump them all in the middle of the floor. That's what we're doing here. We have boxes of different sizes of things that all get dumped in the middle of the floor. And the question is, how many do we have at the end? Well, we count them all up, right? Legitimately, what we would have done in my situation I just described is you would probably have to count. You'd probably put them in like these piles of things to count them up in a convenient way. But that's what's going on here. So imagine here we have, in this case, some boxes of crayons instead of the 1s, 8s, and 64s. We have boxes that have 1, like that's my original 1s place. But there's also boxes that have things that have 2. They come in sets of 2, right? Some things that come in sets of 4, and some things that come in sets of 8. So one person brought in a set of 8. Nobody brought in a set of 2, and nobody brought in a set of 4, and one person brought in a single one. Right? So one person that brought in the set of 8, there's 8 items in their set. And the one person who brought in their lone little piece, whatever, there's 8 of theirs, and they have one of theirs. We have one of theirs. There's 9 total. We'll do that analogy in reverse in just a moment. Let's do part B and do it with base 12. The process is the same. This is a 3-digit number. It's a T, a 0, and a 0. We always have the 1s place on the right. What base am I in? 12. So the place right beside the 1s place is the 12s place because it's base 12. What will come after the 12s place? Yeah, 12 squared. And I'll just write it in as 12 squared. The last thing that I need to know in order to do this problem is what in the world is T?
10.
T is 10. Okay? So when I'm looking at creating the expanded form, I've got 10, because it was T, in the 12 squareds place. Plus, I have 0 in the 12s place. Plus, I have 0 in the 1s place. And before you ask, you don't have to write the 0 times things. But I want, when you go back to your notes, to know where that went. So that's why I'm using them as placeholders right now, because most of yours aren't going to just have a bunch of zeros everywhere. They're going to have other numbers in there. Okay? So what is 12 squared?
144.
144. So we have 10 times 144. And each of these others happen to be 0 on ours, so they're 0 and 0. And what is 10 times 144?
1,440.
1,440. What do you think? Okay. It's all about multiplication and addition, right? We're going to reverse the process. Now we're going to start with one of our numbers, and we're going to put it into one of these other base numbers. So imagine that we instead have those giant pile of crayons come in. We just come into the class, and there's just crayons all over the floor. Right? It would be a great day. I might just lose a little bit of my soul if I saw crayons all over the floor when I walked in. But imagine there's crayons all over the floor, and you've got all these like empty boxes that you're supposed to fill, right? You've got the 64 box, you've got the 8 box, and you've got, you know, the leftover crayons that don't have a home left when they're done. There's not going to be a whole bunch of them. There's just going to be a few, but that's what you have. Well, what you do is you fill all that you can into the 64 box first, right? All the 64 boxes get filled first, because that's going to be your best bang for your buck, right? In terms of like finding a home for things. And then once you don't have 64 left to put in a box, maybe there's like 60 left at that point. You start filling the boxes that have 8s, right? 8 in this one, and 8 in this one, and 8 in this one. And eventually you have fewer than 8 left. You can't fill another box, and you have maybe like 5 crayons left. So there's 5 little leftovers. So you've got some boxes of 64s, you've got some boxes of 8s, and you've got the few leftovers at the end. And what we just did is a process of dividing. We divided up the crayons into different sizes of groups, right? That's what we're doing when we're doing this. We start with the big giant pile of whatever. You can use, crayons is just what I used as an example. You get this big giant pile of whatever, and you consider the expanded form. That's what I did when I told you there was boxes of 64 and boxes of 8. I considered the expanded form, okay? And then you use the division scaffold where you actually divide by 64. And then you divide by 8, and then you divide by 1. So let's do one so you can see how it works. We're going to do a base 4 one. So we have 11,028 crayons on the floor.
That's a lot.
It's a lot of crayons. But our boxes are not boxes of 64, 8, and 1. They're boxes that are powers of 4. So we need to figure out what powers of 4 look like. And we're just going to write out a bunch of them until we get to being a number bigger than 11,000. Okay? So we've got the ones place. That's cool. You've got 4's place. That's fine. And then we have 4 squared. So what's 4 squared? I'm just going to write the value underneath it so that we can have a reminder. It, 16.
Oh, sorry.
16, yeah. After 4 squared, we have 4 cubed. What's 4 cubed? 64. And then we have 4 to the 4th. What's 4 to the 4th?
256.
256. Calculator's going to be your friend in these, right? After 4 to the 4th, we'd have
1,024.
4 to the 5th, which is 1,000. What was it?
1,024.
1,024. And then we'd have 4 to the 6th. We were almost finished. What is that one?
4,096.
And what happens if we get to 4 to the 7th?
16,000.
Yeah. So 4 to the 7th is 16,198? 384? Oh, because times 4. All right, 384. Thank you, yes. That's too big. So I said that's too big. Why is it too big?
That's more than 11,000.
It's more than 11,000 we started with. Okay, so we've got all of our powers written out. And do you remember we did division scaffolding before? What we do is we do those top hats. So the number we have, 11,028, goes inside of the top hat. And we start with the biggest place value that we have, 4096. So 4,096. And we divide, and we want to know how many whole number of times it goes in. So how many whole 4096s go into 11,028? What'd you get? 2. And then what is 2 times 4,098? 8,000 something.
8,192.
Yep. Good. All right, and then we're going to subtract.
Wait, what did we get 8,000?
We multiply the number you just told me, the 2, by the 4096. It's equivalent, Mackenzie, to having, when we do it like with the 2 on the top, normal division, we would put a 2 on the top of our division bar. We're just shifting it to the right-hand side so that it's out of the way. So it's like having the 2 on top. What do I get when I subtract?
2,836.
Having a little bit of dyslexia this morning, I guess, or this afternoon. Get my numbers backwards. All right, we have 2,836. We have to go down the list with all the numbers. Don't go skipping anything, even if it doesn't work, quote unquote. We did 4096. Now we're going to do 1,024. So 1,024 is on the outside on the left. How many 1,024s are there in 2,836?
2.
There are 2. And what is 2 times 1,024?
2,048.
Yes. 2,048. And I subtract. What is the difference of those values? 788. Okay, so we've done the 1,024. What will divide by next?
256.
256. That's our next one. 256. How many 256s are there in 788? 3. 3 times 256 is 768. And if we subtract, we get 20. And it's really, really tempting, but we are not going to skip the 64. We don't skip it. It's got to include it, okay? 64 is over here. Sorry. They're lengthy. 64, it goes in 0 times, right? But this 0 is a placeholder, and if we've learned anything from all these other systems is that 0 placeholders are really important, and not having zeros causes problems, right? So that 0 placeholder needs to be present. So again, it's going to be a 0. I'm not subtracting anything from the 20. I still have 20. But that 0 placeholder matters. After the 64, what shall I divide by? 16. So here's a 16. How many 16s are there in 20? 1. That gives me a remainder of 4, which happens to be the next thing I'm dividing by. 4 goes in 1 time. The remainder is 0. I am not done, however. I have to divide by 1. We'll always go 1 to the very end. Division by 1 is our last step. Clearly there's nothing else to divide into. It's 0. But again, that 0 placeholder matters. And here's the cool thing compared to what we were doing in the other systems. The answer to the question is right here. Don't have to change any symbols, nothing.
Mine's not satisfying.
That's the number. 2, 2, 3, 0, 1, 1, 0. And we need to write that we are in base 4. Now, basic rule of thumb. We started out with something that was a 5-digit number, right? 11,028 has 5 digits. And when I changed it to a base 4 number, right, the base is smaller. My base was a base 10, and now this is base 4, right? I end up with more digits. Okay? So if you change the base to be smaller, your digits become more of them. We get more digits. And that should make sense because we don't have as many numbers I can use. If I'm in base 4, I don't have any 4s, I don't have any 5s, I don't have any 8s. There's fewer numbers to use, so clearly I'm going to have more numbers in my answer than I started with because I have fewer options of numbers to use. Okay, I think there's one more. Does that look right?
Yep.
Okay, so we have the number 99,999, and we're going to put it into base 9. Okay, so are we going to get more numbers or fewer numbers? More. Because we're in base 10. This is a base 10 number right now, right? 99,999 is base 10. And I know it's base 10 because it doesn't say what it is. If it doesn't say that it's a base something else number, it's a base 10 number. Okay? So we have a base 10 number. I'm going to go down 1 base to base 9. I expect to have more than 5 numbers in my answer. So we need to know powers of 9. So the first one is 1, and the second one is 9. Those we get automatically because I'm in 1 is always there. 9 is the base. And then I have 9 squared. What's 9 squared? 81. And then I have 9 cubed, which is 729. And I have 9 to the 4th.
6,561.
Okay, I'm already at 6,000, and my number is 99,000. So I'm getting close. I mean, already just this few. How about 9 to the 5th? 59,049. And if I go 9 to the 6th, what happens?
531,441.
It's big, right? Too big. It's supposed to be 99,000. This is 531,000. So I don't need that place. Okay, so we go back, and we're going to do division with 99,999. And the first thing I will divide by is 59,049. So you probably don't need your calculator to tell me how many times this goes in. How many times is 59,000 going to go into 99,000?
One.
Once. So this piece right there is a pretty quick deciphering. So 59,049 gets subtracted. What is the difference that I get?
40,950.
40,950. Okay, so I've divided by 5949. What's the next 59,000 to 49? What's the next value I'm going to do? 6,561. So how many 6,561s are there in 40,950? 6?
Mm-hmm.
Okay, what's 6 times 6,561?
39,366.
Okay, and we subtract. What do we get when we subtract?
1,584.
Fantastic. What will I divide by next? 729. How many 729s are there in 1,584? 2. And 729 times 2 is 1,458. So let's subtract. 1,584 minus 1,458. 126. What will I divide by next? 81. How many 81s are there in 126? 1. Yeah, just 1. And if I subtract, I get 45. Now what will I divide by? 9. How many 9s are there in 45? And 5 times 9 is 45. Am I done?
No.
No. What's my last step?
Divided by 1.
Divide by 1, right, which gives me a 0.
Sorry, I was reading.
Yep, no, you're fine. We always divide by 1 as our last step. So every single division factor on the left matches my list on the top, right? All the way down, no skips, no repeats. If you have to repeat, it means that you didn't divide it into enough times, you missed something along the way. Then your answer is on the right-hand side. How many digits are in this particular answer?
6.
Yep, 162,150. Oh, that doesn't look good. Let's try again. 50. And what am I missing?
9.
9. I need to write the subscript word 9 next to it. This is base 9. There are 6 digits. That is not a surprise to us. We expected it to be more than 5, and it was. All right.